Let's take a look at another example. Here we want to find the acceleration of a motorboat that reaches a speed of 15 miles per hour in 12 seconds. Before we can even think about solving this problem, we must make sure we have consistent units. In this case, speed is given to us in miles per hour, but we should have speed in feet per second. This means we must first convert our speed from miles per hour into feet per second. We will start out by writing 15 miles per hour as a fraction over 1. Then, since miles per hour is in the numerator initially, we will put miles per hour in the denominator of our conversion factor. We know that 1.47 feet per second is equal to 1 mile per hour, so we can fill in those numbers, cross out the unwanted units of miles per hour, and multiply across. This gives us 15 miles per hour is equal to 22.05 feet per second. Now that we have correct units, we can look at our equation circle to figure out a formula for acceleration. Covering up acceleration, we see that we are left with change in speed divided by time. One hint, whenever we have an initial speed of 0, our final speed will always be the same thing as our change in speed. So here, our change in speed will be our final speed of 22.05 feet per second, and time is 12 seconds. Dividing, we see that our acceleration is 1.84 feet per second squared. Let's look at another example. Acceleration due to gravity is 9.8 meters per second squared. A baseball is dropped from a tall building, has a speed of 92 meters per second when it hits the ground below. We want to know how long it takes for that ball to hit the ground. In this problem, how long would be time? Looking at our equation circle, for time, and covering up time, we see that we are left with change in speed divided by acceleration. Since the ball is initially not moving, its change in speed will be the final speed of 92 meters per second. Our acceleration, we are told, is 9.8 meters per second squared. Dividing 92 meters per second by 9.8 meters per second squared, we are left with approximately 9.39 seconds. Again, if you are unsure of your units, go back to the equation circles with the units. Now we want to find the average speed of the ball. Our acceleration is constant, so average speed will be the initial speed plus the final speed divided by 2. Our initial speed is still 0 since the ball is not moving initially. The final speed is 92 meters per second, so our average speed is 92 meters per second divided by 2, which is 46 meters per second. Last, we want to know how tall is the building. The height in this case would be the same thing as a distance. Since we have uniformly accelerated motion, our distance is equal to the average speed multiplied by time. We found that the average speed in the last part was 46 meters per second, and we found the time in the first part, which was 9.39 seconds. Multiplying 46 meters per second by 9.39 seconds, we see that the total distance or height of the building is 432 meters. To give you an idea of how tall this is, we're talking roughly the same height as the Willis Tower in Chicago. This concludes our discussion on acceleration, speed, and time.